Let's get started looking at an example of when a rebase can be dangerous. We're going to keep this example a little bit simple, just for time, and so that we don't get into one of those complex scenarios that can really mess up your version control. But this will illustrate some of the dangers, and it'll allow us to explain some good practices that can help you avoid making a rebase dangerous. Let's take a look at this simple example. We have A and B, just like we did before. I'm going to make this one a little bit easier to read by adding in some labels. So in this scenario, we're going to have you decide to make a branch and start building your new feature in this branch. While you're doing this, others are going to continue committing onto the tree. They're going to commit to the main branch and push in their changes, and you'll keep working in your feature. In order for you to access your feature from any computer, you push your branch to the central repository. This means that someone else can start their own work using your branch. I've represented this here with another developer who has started working locally with your branch. Once you're done with your feature, it's fully tested, and you decide to push it back in for everyone else to use it, you rebase it onto the main branch and push it out for everyone to use. Since you know that it's going to work, you've rebased it in, and you now have two new commits. You'll notice that D and E are no longer the same as they were before. They have new IDs because they're based on a new base. That's why I've colored them with a different border, and they look a little bit different from the other one. That's just to represent that change. Now that G and H are depending on the old D and E, they're now depending on these obsolete changes. The D and E they depend on are not going to be merged back in, since we already rebased in a D and E change already. Let's take a look at where things can go wrong from here. Imagine that you've told the other developer about your rebase. Now that other developer can rebase onto the new branch, or I should say the original branch. This mostly avoids the issue. The other developer may not have wanted that F commit, you'll notice, that started getting built off of this, but as long as they know to avoid it, they can rebase onto E and continue working there. That other developer might not have been working on a feature that may have been a custom build of your software for a client or something along the likes of that, at which point F needs to be avoided. Let's go ahead and take a look at what might have happened differently. So if we back up and take a look at where we were before the other developer rebased, this time let's imagine that the other developer was working locally, and we didn't know that they were using the code, and they decide to merge in. When they do this, they're going to end up with a new merge commit I, just like we saw in our merge examples, and in this case, they'll have a duplicate set of D and E that get merged in. Since D and E have the original version based on B and the new version based on C, Git considers these to be two entirely separate commits. Because of this, we end up with potential problems and conflicts. Likely both of those are altering some of the same files. It's possible that they've been moved around or changed, and if that happened, then we could end up with a duplicate of the code. Either way, it's a messy situation that we now need to work our way out of. Is it unrecoverable? No. But it is a little bit dangerous, because we end up with a whole bunch of duplicate changes and a lot of conflicts, and so it's hard to tell which pieces need to change and which pieces were just duplicates caused by two D and E commits. Either way, it's a scenario that we want to avoid.